right, we're back for a quick session today. We're gonna interrupt the DSPy series and do something a bit different. And what I'd like to do is earlier, I just happened to discover a bug in this popular package called, or popular Python project called GEPA, which is also related to all the DSPy we've been doing. And I'd like to reproduce that bug and fix it by fixing the GEPA package. So let's put something on and let's start. So I'm starting from a clean slate here, and first thing I'd like to do is I'd like to reproduce the bug, right? Let's think about this. Now, fortunately, I have UV, which is going to be really easy. Now, this bug occurs when we use a combination of the GEPA package, the latest version, and also the latest DSPy, which just came out like 6 hours ago. It's a pretty fresh bug. But let's let's see, how should we do this? Okay, so let's take a quick look at UV first, so we know kind of what we're dealing with, because what we like to do is we like standalone scripts, and UV also has scripts. Okay, so you can initialize a Python script with UV with dependencies, and you can run it with dependencies. It also has this nice way of including dependencies as sort of inside the script as metadata, which is this is actually valid Python. Actually, I'm not sure if it's Python syntax. It's got to be UV syntax, but still. Now, so we can just have two scripts side by side, right? One of them uses the older DSPy and GEPA. The new one uses the newer DSPy and GEPA, and that's it. One of them should not work. The other one should work, so that reproduces the bug. And then we want to change the GEPA library on disk so that when we run the script that didn't work again, now it works. Now, the only trickery there is that we can't source GEPA from the internet. We have to source it from disk. So we just need one thing that I don't really know. So UV local dependency. How do I tell UV to look at the on disk location on Windows 2? A path. So okay, so I can add the UV add. But does it have to be a wheel? Oh, to add a path for the path of a wheel, a source distribution. Oh no, a directory containing a Py project toml. Okay, so I just specified the GEPA directory on disk, and I can add this to a script. Okay, perfect. Wow, nice. So then let's initialize our first script, the one that does work. Okay, so we'll call it UV init. Script working.py. And actually, let's do this. Well, we have the GEPA folder here. Yeah, let's also have the script. No, let's have the script outside of the GitHub repo. We don't want to taint this, right? So we'll just go outside and we'll say, no, we'll make a directory called GEPA repro. Okay, and we'll go inside there, and this is where we'll work. Okay, so now we can do UV. Let's also do a UV self upgrade. Maybe we need to upgrade UV update. Sorry, UV self update. UV can easily update itself, and it just did it from 918 to 922. Magic. Okay, now let's do uv init, the init dash dash script working dot py. Okay, Python, let's do it 3.13. Okay. Is it not like this? My bad. How do I specify Python? Is it Python space? Creating a Python. Oh, here it is. Dash dash Python. Okay. Dash dash. Working.py dash dash Python 3.13. Okay, that's it. We have a script working.py. So now we can open this here, which is one folder higher, GEPA repro working.py, and it already has this metadata. Perfect. I guess we can leave the main structure here. It's not. Let's not do this, right? We want the script to be a bit simpler. Okay, so print hello from working.py, that's it. Now, we need to add two dependencies to this script. uv add dash, how do we add the dependency to a script in uv? Oh, here it is, add dash dash script, okay. Now we have to be careful, so let's add first the DSPy. Okay, so uv dash dash script working. And we're going to say DSPy equals 304. This is the one that does work. There we go. Everything is resolved. So now our script has DSPy. Now the other thing we have to do is we need to add GEPA, but we need to specify the path. So what if I do C users streaming GEPA? Nuh-uh. Oh, okay. So there's no version of GEPA 017 because your card could your chart. Okay, so for the working one, let's add the GEPA from the internet. And let's add it like they want it here. Well, actually, let's do greater or equal to 0017. Is it gonna pull in? Yeah. So can I add exactly a greater version then, or is it still gonna... Nah, it wants 0017 exactly. Okay, so might as well add this one. Interesting. So we'll be forced to use whatever GEPA DSPy 3.1 wants to. I think we can sort of trick that. Okay, so now let's get the quick working GEPA example, right? So we just have import DSPy. Well, actually, do I even need the DSPy drags GEPA along with it, right? Yeah. Interesting. Okay, so what do we need to create the most minimal GEPA example? Well, we need the most basic DSPy signature. So my signature, DSPy is a subclass of signature. And the most basic DSPy signature, it only has an input, which is a DSPy input field without the description. It also has an output, which is a string, DSPy.output field without any description. That's it. We have a valid DSPy signature. And what else do we need to run GEPA? Well, we need a metric function. And I think that's it. we should just be able to run it. Of course, we need the DSPy language model. Whoops, sorry, forgot about that. Yeah, so we have to instantiate DSPy language model. So, and we need a reflection model from GEPA. Okay, so then we know how to do all this because we this is what we're working on the DSPy project, right? So let's see, how do we get... Here we go. We know how to get a language model. And we're going to set this to DSPy. So it's our free open router model. What else do we need? We need a reflection language model for GEPA, which will have exactly the same. We don't care, but we're not going to configure this one to be the model. Okay, we're done. Then we need a metric function, and the metric function in GEPA has to look in a certain way. Now for that, we'll have to look. Let's see, do they tell us how? Oh, here we go. We found it. So we have a metric function. I'm sorry, what's happening here? Oh, there is a copy button that I'm not seeing. Gotcha. Okay, we can delete all this. It has to return a float or a score with feedback. Example is actually DSPy example. Prediction is DSPy.prediction. What is this trace? Optional is from typing. And where are these DSPy.score with feedback? Where is this coming from, I wonder? Okay, so then once we get GEPA, DSPy example, new program, that's it. GEPA compile. So we need these lines of code to actually run prompt optimization, but that's not what we really want to do today. We just want to find that bug and fix it quickly. Metric, track stats equals true. DSPy example, in our case, we're just going to run on one example. And we're just going to call this the train set. We don't need the Pareto frontier. And we're also going to use the same training set for the validation set. Okay. Our student will be DSPy predict with this signature, with my signature. We are almost done. So we need to import... Oh yeah, we need to solve the metric. The metric will always return 0, 0, so it's a fake metric. We're done there. Where do I import GEPA from? And we need one more example. So the example will be, it will have input, and output, the most basic example. I just need to import GEPA, and these typing thingies here. Where the heck is score with feedback from, I wonder? Score with feedback, where did I see that before? Score with feedback. There's a full... Okay, we have to look inside the GEPA source code because we don't know. So DSPy, GitHub, DSPy, teleprompt, GEPA. Here's all the thingies here. Score with feedback from DSPy, teleprompt, GEPA utils. Okay. We need this. Score width and the trace we need. We found that one too. Okay. This is just a Pylance issue. It's fine because this script will actually run. And we finally need GEPA itself, which we find... Is it from GEPA, import GEPA? Where do I get GEPA from? Like the actual thing. Come on. GEPA optimization engine. GEPA captures. Can also use as batch inference. Where do I find this import? Oh, it's dspy.jepa. Okay, we're done. Yeah, we are done. Okay, it's actually dspy.jepa. Okay, so now if we do UV run, working.py, this should work now. Okay, it installs the whole environment. Yep. Oh, I see. I have to set, when I do GEPA, I have to set exactly one of max metric calls. One. All right, so let's just train for one step. Okay, I'll run again. GEPA requires a reflection language model, of course. So I also need a reflection LM, which is the reflection LM that we used. Now we really should be done now. I believe so. Okay. Yep, there we go. We are done. No, we're not done. Inputs have not been set for this example. DSPy example. What is a DSPy example? I think I've seen this before, but I forgot. How do I set the inputs? Oh, I see. I have to tell it which is an input. With inputs. Input, I believe, right? Example with inputs to set them. Okay, we're actually done now. So we are. Yeah, we're done, but we have to give it like 2 steps because it uses the first step to like check what the score is, and then we're not actually doing anything. There we go, 1 out of 2. Okay, we're done. So the whole thing worked. It optimizes the prompt. So now let's break it. Very easy. We break it by... Now we would like to pin this GEPA though to 0024. And actually, will this work? So can I force run UV with dependencies? UV force run. UV ignore conflicts or something. Because UV is not letting us run this, but we kind of want to just run it. Come on. Unless you declare them as conflicting dependencies. Optional dependencies group. We use supports explicit. No, not groups. Force, update, upgrade. Seriously, this is what... It seems like this is what I am stuck on. This is what we're stuck on because we don't know how to force UV to just run because it wants a strict match there. Come on. No, these are true. UV also respects Python. We don't care using a shebang. We don't care using alternative package indexes. Yes, we do care about this because we're gonna need the local one. We're actually gonna need this. Yeah, because we're gonna have an index location, but where do we... Once locked, port script will not create a log file. Exclude newer. No, we don't want to exclude newer. Using different Python, using GUI. Interesting. So UV force run is not a thing. UV cheat sheet. UV run. Is there a force? Options, active, all extras, all groups, all packages, allowing secure host. No. Cache color, compile, config. Default index. Directory, environment file, exact. No, not exact, the opposite of exact. Extra, find links, fork, strategy, frozen, group, GUI. Index strategy, isolated, no, keyring, link, locked, manage, native, no binary package, no build. Come on, no config, avoid discovering configuration files. No. No dev, no editable, no environment file, no extra. No project. No sources. Ignore the true UV when resolving dependencies. No sync. No sync? Avoid syncing the virtual environment. Is it no sync? UV run dash dash. No sync? Nope, it is not no sync. Because DSPy depends on require, we can run it, but because you require GEPA. Offline, only dev, only group, package, pre-release. No project, no Python. Python platform, no. Quiet, refresh, reinstall resolution. No, the strategy to incompatibility, it's not compatible. Upgrade. Allow package upgrades. Oh, maybe this? So we want to allow an upgrade. Oh. Close. No, it wants it exactly. Width. Aha, here it is. With these dependencies are allowed to conflict. There we go. So we remove GEPA from here. Okay, and now we can run the working again. Oh, I forgot to save this, sorry. There we go. So now DSPy pulls its own and everything works, but then if we put the with, when using the project, these dependencies will be layered on top of the project environment in the separate. These dependencies are allowed to conflict. There we go. So this is our magic. Right, so everything works. And now I just do UV run with GEPA equals 0024. Perfect. So now the working, this should still work. GEPA by itself should work with the DSPy wants an exact version, but this doesn't matter from GEPA's point of view. It shouldn't. Yep, there we go. Works. Perfect. And well, actually, we don't even need this then, because we can make it even easier then. All right. Just UV run with GEPA and with DSPy 304. Aha. It doesn't work because this one must be on top of this. Okay, good. So now we just instantiate our non-working broken.py, which is exactly this, but with DSPy 310, which just got released. And we're gonna see some magic because now when we run, finally, we're going to see broken. Okay, it's installing DSPy to the latest one, GEPA the latest one, which should be fine. There's no conflicts there. I know what's happening. It's not a reasoning model, so the bug that we found happens only for reasoning reflection models. Oh no, there it is. Nope. No. There it is. There it is. There's the bug. We got the bug. We have an error. Dict object has no attribute strip. Okay. The last thing we need is with. We need to specify a source here. So how do I specify UV run with? Can I do a location like C users streaming GEPA with the one on disk? Yes, I can. Perfect. There we go. So now we run the broken one, which is exactly the GEPA main. We run the broken one with the GEPA main, and now we can do local development. Okay, so the bug, there's the bug. Okay, so the bug is in GEPA. Source, GEPA, proposer, reflective mutation, base. Let's breakpoint here to see exactly what the bug is. And we're gonna find a miracle here. Now, we run with the local. I'm curious if this breakpoint change takes effect or if the environment is already synced, it won't detect that change in my file. I don't think it does. There's a trickery here. I have to clean the environment somehow. Or should it be? Yeah, it didn't stop there. Yeah, because it's cache. Okay, very good. So UV cache clear, clean. Now it's gonna force rebuild the environment with my modified file. Again, so let's run the broken again. Yep, it's rebuilding everything, and it's also gonna build my local GEPA again. There it is. Okay, so now this is how easy UV makes it, because now I have my breakpoint here. And I should stop exactly here, and I should get this LM, and I'll see it is not a string, even though they tried to strip it. Strip is a Python method for a string for the string class, and this will not there we go. So then we call output lm full output, full prompt, and type output. Whoops, it's a dictionary with keys, text, and reasoning content. This is a change that's introduced by the most recent DSPy, but the point is, so GEPA no longer works with the most recent DSPy because the output of the raw, this is the DSPy LM, okay, so the language model. Although it's a let's see, what is this protocol? Interesting, special form. This is a DSPy LM. Although it's pretty complicated to see that. Not straightforward at all. But the point is, the fix is relatively easy now. Okay, so what they meant to say here is LM out. First you get the actual LM out, and then we say if type LM out not in string dict raise we need to raise some error. Then what we want to do, if the type of LM out is dict, we just want to say LM out is LM out at the key text, and then LM out becomes LM out dot strip. Okay, we just need to figure out what kind of Python error do we want to raise when, if in the future something weird changes and the LM call. See, the call method here is wrong because this should now be a string or a dict. This can be called text out. No, is the typing, is the thingy gonna yell here? No, this should be fine, right? I can redeclare this as a string. String dict is not assignable to declare type string. No, I cannot do this. I can't type check this. So what do we want to raise before we figure that out? So Python errors. What kind of exception do we want to raise? Type error. Yeah, type error seems appropriate. So we want to raise a type error. Type error. Python custom type error. Python raise type error. Okay, it's just it takes a string then. Okay, so we just want to raise a type error. The output of the LM call should be or dict. That's it. So now I do UV cache clean. Remember, I changed my GEPA. Let's ignore the typing errors for now, and then I UV run the broken script with the GEPA I fixed locally, which is 1, 2, 3, 4, 5, 6, 7, 8 lines of change code. I can get this to 7. Let's see it work first. So this should definitely be a dict now, and if it's a dict, we'll first extract the text and then we'll strip it and everything should flow. That's it. We just fixed a bug in a state-of-the-art AI package. You know, oh, we did not fix a bug. Did we not? Oh, there's a rate limit. Oh, okay. I hit the rate limit on my Open Router account. But yeah, anyways, the bug is reasonably fixed. We'll have to wait for this rate limit to end. Now, while we do that, let's figure out how we. Then if I go back to GEPA and I have a diff now, right? Yes, I do have a diff. I want to check out the branch and I will call it fix LM out type. Okay, so we're on a branch now. What I don't like though is, let's see, do they have a pre-commit here, or can I run a pre-commit? Dev? Yes, I can run a pre-commit. So UV sync all extras. I can sync my development environment now. This is the nice thing about UV scripts, because I can go back and run the broken script, which is now fixed, anytime I want to. I still keep a local environment here. Yeah, UV is amazing. Okay, so I did the thing, and now I want to run UV pre-commit run all. I want to see if I get if it yells about typing errors. I need to UV Python install 3.11. This is how easy it is to even install Python with UV, because it just wants 3.11, and I am done now. I just installed Python 3.11 on Windows. Like 3 years ago, this would have been impossible. No Python. I believe I have to restart this console. Let's see, is there a Python now? So UV run. Come on, I just bragged about UV. Check the log at streaming cache. Okay, let's check the log then. What does it want? Cache pre-commit dot log. I wonder if I just commit. No, because it will want a Python, right? Yeah, it does want a Python. Interesting. So you're telling me I cannot commit this, right? Expect dict. I can't commit it, but the pre-commit still doesn't work. Oh yeah, because is this like does pre-commit not work on Windows? This is a pre-commit issue. Okay, so we're gonna have to fix this blind then. Now the problem we have is, let's see, so we have an LM out, which is either a string or a dict. If it's not a string or a dict, we raise an error. Okay. Now, if it is a dict, we want to peel it off. And we'll just call it text out. Let's see. Okay. Else I have to do this, right? LM out. I guess we can do this, right? We can simplify this logic and then we can say text LM out dot strip. Nah, because this can still be because it still wants yeah, we haven't done anything, so let's see. So if the type is not a string or a dict, yeah, this we definitely want because we annotated this, right? This should be dict from string to string. Okay, if this helps. It doesn't help. Okay, so then we can just do everything, right? So then the text out, else text out is LM out. No, the call here should well, we don't need this, we just need strip. Okay, else this is it. Okay, this is much cleaner now. So there we go, we solved it, right? So we get the LM out, which is the full prompt, and if the type is, let's start with the string first. All right, then we just strip. If the type, else if it's a dict, we first get the key and then we strip, else we raise a value, right? The type, the output of the LM call should be string or dict. How many changes? 1, 2, 3, 4, 5, 6, 7, 8, but 2 white spaces. I think this is the cleanest we can get it, right? No more pre-commit errors. How do we convert all the, well, rough format, source, GEPA, proposer. Let's see what this guy wants to do. Well, actually, before we do that, let me status git add source GEPA reflective mutation. Do I have a commit here? Yeah. So I'm just gonna add it. Proposer, reflective, base. Okay, commit, cleaner, logic, cleanup. Typing. Okay, and can I do UVX rough format? Let's see what it does first. Reflective base. Shouldn't do too much. Okay, I see. It did the yeah. Okay. It applied yeah. So we want this because these are my changes, right? Source. GEPA proposer reflective base. Formatting. That's it. We now fixed the bug. Code is clean. And we're done. So just gotta be careful here, right? The bug was that DSPy 3.1. Now let's actually look at what the bug is, okay? Now that we have some time. So let's install DSPy 3.1. Okay, we can't install it here. Where can we install it? We know where we can install it. We have it in our... Actually, we have DSPy 3.1 in the DSPy project we've been working on. So let's... Okay, this is done. We finished the branch. So I'll push this to GitHub and open the PR. But here's the real bug. So if we go back to our regular project, we actually already have DSPy 3.1. And we're on Python 3.14 too, not that it matters. Now DSPy in 3.1, it has completely new thing. It actually has a reasoning class, which is pretty wild. That's a big change. If I knew where it was, signatures, it's gotta be here somewhere. Predict. Oh, and adapters maybe. Is it? DSPy reasoning. Where the heck is it? No, it's not here. Let's see. Okay, no worries. So DSPy. Where did they add the reasoning? I swear I saw this. Oh, we can't search code without being logged in. Is it not adapters? Types. Here it is. Adapters types. Adapters types. Reasoning. Right. So this is a gigantic new feature where they can actually capture the reasoning from models in the output of the language model. And the bug is really, really simple because let's search for this text field. Oh, it's not here? Come on. Gotta be here somewhere. Who uses reasoning? Oh, it's the base LM, right? Or the base adapter. Let's see. Yep, they use reasoning here. Actually, we talked about this in the first stream because I was wondering what the heck is the citations. It was another special thing, but now this reasoning, which is way more common to people. I think it's in primitives. Predict? Where is the base model in DSPy? Clients, base LM. Here it is. So, see? The output has this, it used to have this text field. This was always there. And something used to happen before. If every output only has the text key, they used to strip it and it was a plain string. That's exactly why GEPA is broken now, because now the output length is no longer 1. This measures how many keys are in there. And now when we also have reasoning, we have 2 keys, text and reasoning. This line doesn't take effect anymore, so the output is a dictionary. Which, this is bad. This is not even typed, right? This starts off as I'm sorry, it's a list of dictionaries, right? Not a list of strings, right? Exactly. So this is bad because it's not typed here. This should be typed in DSPy, right? It should be list of either string or dict, from string to string. This or here is exactly the bug we saw and we fixed. And that's it. We are done. Small bug, but still not the smallest, right? You gotta know what you're doing. Yeah, so this was a short stream. Short video. Thanks for watching.